Fantastic. Hello there, Master Hellish here, and welcome to this extra episode of CodinGame. Today we're going to be looking at Mars Lander episode 2. I'm excited to give this a try because I enjoyed the last one, and this one's going to be a little bit more complicated. So if you haven't seen my previous episode, Mars Lander episode 1, go check it out. There's a link to the playlist in the description of the YouTube video. So go have a look at that and then come back to this one. But we're doing an extra special episode today because I'm announcing and telling you a little bit about Hour of Code. Now, Hour of Code is a 1-hour introduction to computer science type event which is designed to demystify kind of code and programming and show that anybody can learn the basics of programming, and it's also to show that there is a very broad field of code in computer science and to show how important it is to not only our lives today but very important in the future. So the coding event takes place during Computer Science Education Week. Okay, so it starts on the 5th of December to the 11th of December. So if you're watching this video on the day it comes out, it's starting all tomorrow, and I'm doing a special live stream on the Wednesday starting at 5 o'clock in the afternoon UK time until, well, it's an hour, so it's going to be until 6 o'clock. So if you want to check that out, the link to the description of the Facebook event and where you can find the live event, and also it's all going to be in the description of the video, so go check that out, get involved. If you don't know code, this is a brilliant time to come along. You can ask questions in a Twitch chat. I'll try and answer everybody's questions. I will step everybody through about what code is and the basics of it, how you can do it, and by the end of it, if you have a Windows computer, we will have written a program together. Also, we'll be coming into CodinGame to see what the way that they're participating in this event. There are some special kind of bot programs which they've got going. I've done the first one, I had a look at it, and I'm quite excited to do the rest. So main message here is computer science is very important, code is very important, and we're having an event next week all across the world, and I'm going to be doing a live stream on the Wednesday. So come along to the live stream, check that out, check out the other links in the description to find out more about code. It's really important for people of all ages. If you're really young and you've got to go through school and stuff still, then you're going to need to know this sort of code stuff for schools. Code is generally taught in a lot of schools, especially in the UK right now, and also it's going to be very important later in life. And of course, even if you're not young, even if you're older, you not only may need to support younger children who are going through that if you're a parent or guardian, but you also may come across it in your everyday life as well, because it's becoming more and more prominent. It's in so many different places, in so many different things. It's coming so integrated into our lives. It's so unreal. You have difficulty really avoiding it in many industries. So it's a really important thing, and it's great to raise awareness of this and get people involved. So if you can't get involved there and then, I will be putting the video on my YouTube channel afterwards. But come live if you can. You can ask questions, get involved. It's going to be great fun. Right. That is all about Hour of Code. If you want to know any more, put some comments down in the comment section of YouTube below. But I am going to now have a crack at Mars Lander episode 2. So first things first, okay, we have to land this rover just like last time. All the angles and variables are the same, and the outputs are the same as well. We need to output the angle we want the rover to be, and we have to output the thrust power, remembering that thrust power 3 will glide us down gently, well, moderately gently. We'll still keep accelerating, and power 4 will slow us down. We can only accelerate down, or we can slow down, because we can't set the thrust power to non-integers. It has to be a whole number. We have to land flat, and we're given a different bit of input. We're given the input of the surface, so we can see all the land and the different points on the land, and that's the first bit I'm interested in. You see this picture here where we have flat ground for landing site. We need to find that landing site and save its location so that we can kind of guide our ship towards it. Now, to do that, what we're going to do is we're going to get the coordinates in, and look, every bit of this landscape is on a slope except the piece of flat land. So what we're looking for is two points which have the same y value. You see y is in the scale up the left hand side here. So if you've got one point after another with the same y value, the line between those 2 points must be a flat line, and that must be our landing site. So to do that, what we're going to do is we are going to first of all dim a couple of variables, because we want some more ones to be used. So we'll put them in up here with the other variables. Now remember, dimming a variable just tells the program that this is a variable. It's our pigeonhole. It's where we're going to store something. So we're going to say, we're going to call it target X, and we're going to have another one, and we're going to call it, have you guessed yet? Yeah, you're probably right. It was target Y. And we're going to dim them both as an integer, because we're going to be storing numbers in them. So there we go, as integer. That's those two all sorted out. So now we can store which ones we want. Okay, now also, as well as them, we need to keep track of what the last coordinate was, because here we have the current land X coordinate and the current Y coordinate when we're reading them in. And what we need to do is kind of find out which one and compare it to the last one and see if it's level. If it's level, then we're going to have to keep an eye on it. Now, that's going to require another variable, so let's dim last Y. Okay, we'll call it last Y, and again that's an integer as well, so let's put that there. Oh, there, now it's last Y. I missed the S out of it. So we've got last Y and we've got our integer. So in this loop here, this is where we read in all the different coordinates of this red zigzag that goes across the screen. So what we need to do is we need to kind of make a decision. Okay, so we want to say that if really as well, for this last Y, we should also set it to something before we get going. We should initialize it. So we're going to set last Y to equal 9999999. There we go. Just to make sure that it's not that it's got a value which we're not using, because the zone is 700 meters wide. So I'm presuming we're getting coordinates by the meter. So if we had this 700, did I say 7,000? So if we had 7,001, that Y value is going to be well out. In fact, no, hang on a minute, because that's Y. We're doing high. Y values up and down. So it could actually be 3,001. That would be out of the range of the Y coordinate. So that's fine. We'll leave it like that. So we're going to say if the land Y value is equal to the last Y value, the Y value before it, then. So this is going to be our condition if we've just got a Y coordinate and it's equal to the previous Y coordinate, so it's nice and level. And then what we want to do is we want to set the target X and Y position. So the target Y position is just going to be that. It is going to be equal to the land Y value. There we go. Our target X position is going to be a little bit more tricky. And for this, we're going to have to track not just the last Y, but we're probably going to have to track the last X as well. So let's do dim last X as integer. Brilliant. And last X as integer, yeah, let's set that to, let's initialize it to, what did I say, 7,001. There we go. So the last, the target for the X is not actually going to be last X, because the last X is going to be the right hand coordinate of the landing site, and what we want is the middle of the landing site. Okay, and there's a little formula that we can use for this. I just worked this out before the episode just to make sure that I wasn't barking up the wrong tree. And what I decided is that if we get the land, okay, ignore the brackets for now, if we get the land and take away the last one, okay, so if we take away last X, so we're getting the current X and take away the last X, that gives us the length of our landing site. To find the middle of the landing site, okay, we want to divide it by 2 to get halfway down the length, and then add on the last coordinate so that we go all the way from the beginning at 0, 0 up to the landing site and then halfway along it. So we get last X again. And that's our formula. Now I'm just going to put it in brackets to make sure that these calculations get executed in the right order. And this isn't necessarily programming, this is maths. This is just maths. The fact that these are variables, there's not really much to it really. And there we go. Jobs are good. And we have done our evaluation, so we need to end our if. So we've decided that if we manage to find the flat piece of land, we're going to set the targets. If we don't find the flat piece of land, then all we do is we just need to set last y and last x so that we record them ready for the next part of the loop. So this is the loop that we're going round and round and round to pick all the different points of the terrain up. So the last y is going to equal to the current land y, and then the last x is going to be equal to the current land x. And there we go. I'm fairly confident that this target y and target x is going to give us the middle of our landing site in coordinates. So that's really the first leg of this done. So what now? Well, we can test it, I guess. What we can do is, you see this console right line here, what we've got is we've got an angle and we've got a thrust. If we change the angle to 0 and the thrust to 3, it's just going to sink down slowly, but we can use this console error right line debug message. Okay, we can use this command here to put something out onto the screen, and what we can put out onto the screen is our target zone, so we can test whether it's the where we think it is. Make sure our code's working. So we're target y, so we put target y, and then we've got this and then a space and then an and, just so there's a space between them. Target x, there we are, target x. Right, now this is going to crash. Well, at least I'm presuming it is, because it's just going to float down slowly-ish and then until it hits the ground. But we should get something written out to the console which will allow us to know what our target y and target x is. So let's do that. Okay, here we go. So there's our craft. It's heading straight down slowly, and you can see this standard error stream. That was our piece of code, the console error right line, and you can see it says 150 4750. So that is the y coordinate first, which is the height of the landing area. So it's the height of the whole thing is 3000, so that being 150 is probably about right, and the other one is 4750. So if this is 7000 long, big crash there. If this is 700 long, then I'm quite happy that the middle of that landing pad, that 4750, seems about right. That'll be about 5000, 6000 and 7000. So we know our target's working. Let's get rid of that debug error message. Brilliant. Okay, so what's next? Well, we know our landing site. Now we need to put a load of conditions in, and I mean lots, because there's lots of different scenarios here. The craft could be need to move to the left, it could need to move to the right, it could need to slow down, it could need to speed up. There's various different scenarios that could be happening here. So the first thing I'm going to do is I'm going to add 2 more variables to this main game loop. The first one, if I dim it correctly, is going to be our angle. This is the angle that we're going to tell the console that we want our ship to be at. And the next one is going to be our thrust. Now, we did this last time, okay, so there's going to be some similarities for this bit, but there's a lot of different scenarios that I can see down here. Look, easy on the right, initial speed correct side, initial speed wrong side, deep canyon, high ground. There's all sorts of weird stuff that we've got to contend with. So we've got lots of different things to do on this one. So thrust, cool, new keyboard, there we are, thrust, and they're all going to be integers as well, so we may as well just do that. Right, so when we write our line to the console, we want to be writing, instead of 03, we want to be writing our angle, and then a gap, and then we want to be writing our thrust. Now, we haven't set what they are going to be yet, but that's what the output's going to be eventually. Now we have this gap here. We need to fill it with some stuff. Well, let's look at this scenario we've got here. It's called easy on the right. The first thing we need to do is move to the right. So what we need to do is we need to say something like, if the target is way over to the right, then move that way more. So we'll put something in here. So let's put a comment in, right of the target. So if we're right of the target, this is what we're going to do. So we need to say if we're right. So let's say if we got x. Yes, so this x here is our current x coordinate. So if our current x coordinate is greater than the target x coordinate, so that's where we want to land, plus, well, we need to say if we've gone past the edge of the landing zone. So the landing zone here to me looks just over 1,000, so let's say plus 600. So if you are to the right hand side of the right hand side of the target, then we need you to blast the other way. So let's put that in. Let's say, let's give it an angle. Let's say the angle is going to be equal to, well, I think the angle I'm going to use for this is 45 degrees, because 45 degrees is an efficient angle for lots of things. Maybe not in reality, but certainly in this sort of world, because you're going to put half your energy into staying up in the air and half your energy into moving you across. It's a good, nice, even split. So we'll say the angle is going to be 45 degrees, I think. And then the thrust, we'll put max throttle. Max throttle to keep ourselves in the air as much as possible. There we are. Equals maximum, which is 4. And then we want to end our if. Okay. So that is if we've gone too far. If we're too far to the right. Now in this scenario, we're too far to the left. So let's say if x. Hang on a minute. Let's do our comment, left of target. So we're left of the target. If the x amount is less than our middle of the landing zone minus 600, so we get the start of the landing zone, then we want to set our angle and thrust to probably, well, the angle is going to be minus 45, and we're going to have the thrust to maximum again. So this should move our craft left and right to get it above the launch area. Once it's above the launch area, I think we're going to put some different constraints in. Okay, so bearing in mind this code executes from top to bottom, and if it matches multiple constraints, the ones at the top get overwritten by the ones at the bottom, because it reads the one at the top, it will set the angle if it matches the constraint, and then it will move down. So let's just say it matched this constraint, then it will set the angle to 45 and the thrust to 4. If for some weird reason, and it won't, it matched this constraint, it will then set the angle to minus 45. So this angle that we're writing to the console is going to end up being minus 45, because that's the last thing it was set to. So let's just run that and see what happens in this particular scenario. I'm expecting it just to tilt to the right and move off. So let's see, your program did not provide an input in time. The Mars lander self-destructed. Well, that's a little bit bad, isn't it? Let's just check here to make sure that we've got everything in that we need. Yeah, that looks good, that looks good. Oh, it's VB, isn't it? In VB we put end if. There we are. This is what you get for doing too many different programming languages. There we are, end if. I reckon that should do it, because the error message was expected if. So, are we going to execute this time? Yes, we are. Right, so our lander is now tilting at 45 degrees to the right at max power, and it's really going for it. There we are. Now, the only problem with this is that we're going to build up way too much horizontal speed. We're going to overshoot the launch pad, and, well, yeah, it's just going to keep going and keep going and keep going. Oh, it's turning back the other way now. So there we are. Once it passed the launch site on the other side, it turned round, but it was far too late. what we need to do is put something that says, if we're on target, if we're on target, we just want to float down. Okay, so if x is let's just steal this bit of code here. If x is that and x is this. Okay, but what we're going to do is we're going to flip the signs around. So in the other bits of code, we're saying, what if we're to the left of the launch pad? What if we're to the right of the launch pad? And in this one, we're saying, well, what if we are actually between the 2 points that define the launch pad? If we are between those 2 points, then we just want to go down. Okay, and to go down, this is the same as what we did in the last episode. We put a little bit of a condition in. So we say, if your horizontal speed is less than minus 38, I think it was, wasn't it, last episode, then we need now, less than 38 means it's falling too fast. If it's falling too fast, then what we want to do is we want to set thrust equal to 4 to give it some extra power. If it's not falling too fast, so else, then we want set the thrust to 3 so that we can fall down at a moderate rate. So we set it to 3. And then that's ending the if. And then we end the main if here. So we're going to end up with some nested if statements. And we're going to get this program working more and more efficient as we go. So this is basically our descent code. Okay, this is what allows us to go down slowly. Now the angle needs to be set on this descent code. Alright, because at this descent we're just going down at 0. There we go. So if we're on target, we activate our descent code and go down. If we're right of the target, we put our angle one way. If we're left of the target, we put our angle the other way. Now, this is not going to be enough on its own, because I know from the last test that we were travelling across that landing zone way too quick. Our horizontal speed, I mean, you can see it accelerating now. Horizontal speed's gone up to 60 meters per second, or whatever the unit of measurement is here. We're coming up to 90. We're going to be at 100 horizontal. Now here, we've now leveled out. This is our on-target code running now. Once we pass the other side, it's going to tilt the other way. But this isn't going to be enough to slow it down. Look at it go. It's gone way too past it. And it crashes. So what we need to do is add a piece of code in now, which is going to stop its horizontal speed from being so high once it's above the landing zone. The first part of that is not allowing the horizontal speed to get so high in the first place. So what we're going to do is we're going to put some nested ifs in here. Oh, that was my phone. Yeah, we're going to put some nested ifs in. So if, and then our condition, which will be if we're going too fast. So if our horizontal speed, so there's horizontal speed. Now if we're to the right of the target, then our horizontal, we're going to be going left, so our horizontal speed is going to be in the negative. So if our horizontal speed is less than minus, let's say 40, we don't want to go too fast, then if we're going fast, if we're moving across the screen really quick, we want to enter some sort of like hover mode, so we just move sidewards without going too quickly. So let's put a hover mode in. So this hover mode, we're going to say that the angle is going to be 0, so we're going to be pointing straight up, and we're going to use our descent code here, but we're going to change it. Okay, so we're going to put that in there. There's our descent code, but we're going to change it from minus 38 to minus 1. So if we hit more than minus 1, we're going to thrust up, and minus 1, so when we're in hover mode, we barely go down at all. We stay up in the air. So we've just put this if in, we've got that in. So basically we're saying if our horizontal speed is above 40 meters per second, we're going to go into a hover mode, else we're going to do what we did previously. We're going to angle at 45 degrees and thrust across the screen. So that's for the right. I'm just going to do the same again for the left. Okay, so there's the code put in for moving left, and it's the same as the one moving right, except we're saying for horizontal speed greater than 40. We're moving to the right, so we're going to have a big positive horizontal speed. And what we should see now is that once our vehicle reaches a horizontal speed of above 40 meters per second, it will point upwards and just hover and just glide acrosswards. So let's see if we can get it to do that now. So the condition starts. Our craft explodes because we're missing an if. We're missing an if. We need an end if here. End if. There we are. Just do a little quick fix. And there it is. It's pointing over to the right at 45 degrees and accelerating away. So this piece of the code is activated. Now it went above 40, so it's in this hover mode here, which is slowly descending, and we don't want that. Oh no, we should have been at a higher thrust. Something's not right. Yeah, if our horizontal speed is less than -1, which it is, our thrust should be 4. And we're still accelerating downwards. Oh, not far from the launch pad. In fact, we just started to turn the other way. So what we were looking at there, I was saying horizontal speed, which is correct for when it was moving right. But when it was going down, that's its vertical speed. And that is the big mistake that I just made. So these ones here, if the vertical speed is less than 1, this is our hover mode we're putting ourselves in now. And this one here, for our descent code, that one should be vertical speed as well. There we go. So if we're going up and down, vertical speed. Right, that should work now. So, same sort of thing here again. We're getting close to actually having something that's going to work now. We're blasting off to the right hand side at the maximum thrust we can. Once we get above the landing zone, the lander is going to level off. It's going to straighten up and start descending. There we go. We're over the landing zone and it's straightened up. The only problem now is that we've got a horizontal speed which is just way too high. And we're going to end up crashing. So what we need, right, is a kind of brake. We need to say if we're above the landing zone and we're moving horizontally, we need to stop that. So let's change our on target code. So this is our descent code. That is fine. But what we need to do is we need to say if we are moving horizontally, okay, anything more, and remember we want to straighten up here, anything less than 0. Anything less than 0. 0, yes, that's fine. Then we want to turn, okay? We want to turn and we want to thrust in the opposite direction as much as possible. So let's say our angle, there we go, our angle. We're going to make it, let's see, if we're on target, but our horizontal speed is less than 0, so we were going the wrong way. We need to see if we can counteract that. So let's try 90 degrees and see what happens, and we'll do thrust 4, just for a short burn, and then we'll do an end, and then we'll say if, yep, the horizontal speed is greater than 0, then we're going to do the opposite. We're going to thrust the other way, and this is hopefully going to level us off so that we don't just go flying sideways too much. It's going to be our brake. There we go. And we're going to just end those two ifs. So there are two brake conditions. Now the descent code wants to come before our brakes. Okay, we want to have that first, so that we have a nice descent code in there. But then, if we need to, we put some horizontal angle and thrust in to do some braking. So let's make sure all our ends say end if, otherwise our code won't work because it's required. There we go. Right, let's give that a try and see if we've got our symbols the right way around. So this time we are blasting off to the right hand side at 45 degrees. We are left of the target. This piece of code here is executing. Okay, we are now above the horizontal speed of 40 degrees. So now this piece of code, the hover mode, is executing. Once we get over the target zone, our brake should kick in. There's our brake, and our brake's the wrong way around. It's accelerating us. Oh my goodness, we're going the wrong way. Ah, dear, oh dear, oh dear, oh dear, oh dear. Right, okay, so let's just pause that. Pause it. There we go. Our brakes are the wrong way around. So our angle there wants to be minus 90, and our angle here wants to be plus 90. I did wonder whether that was the case. Never mind. Let's try again. Okay, so I'm wondering now if this is actually now the finished code. We are moving to the right at a 45-degree angle. Okay, our horizontal speed hits 40, so it then straightens up and goes into a very slow descent, almost a hover. And once it then is above the landing zone, it should use a 90-degree turn to stop the horizontal movement. Okay, so here it comes. There's the 90-degree turn to stop the horizontal movement. Is that going to be too harsh? I think it is too harsh because look, it's now going to struggle to even out again. It's going to turn the other way and it's just going to keep turning and turning. Yep, 90 degrees, way too harsh. Maybe we shouldn't just thrust sideways. I don't think thrusting sideways is ever a good idea. Actually, I can think of... Never mind. Right, so I'm going to change that to 45 degrees so it gently angles itself out as it comes down. See, there's a little bit of trial and error in this sort of thing. Granted, if you're landing the Mars rover for real, you don't really want trial and error. You want to get it right first time. But this is why they do simulations. They do lots of computer simulations to simulate all the different possible things that could go horribly wrong. So here we are. We're now entering above the landing zone. Our horizontal speed is too high, so the lander's going to tilt to try and bleed some of that off. And it does so. There we go. And as it gets to 0, it will tilt back the other way, and it will just bleed that off there and there, and yeah, I think it's just going to bounce backwards and forwards. That 0 is really not. Yeah, I think the 0 is a little bit too precise. It can't level itself out properly. So we're going to say if the horizontal speed, we'll give it a bit of variance. We'll say 2. If the horizontal speed is 2. Then we'll turn it. Oh, we actually fluked to landing. We fluked. It just happened to be at 0 as it landed. Okay, all right. Well, let's just fast forward and jump and try that again. So we're coming over the landing zone again. This time we're saying horizontal speed. We've got a tolerance of 2 on the horizontal speed. It's going to burn us quite hard to the left to slow us down, and then once it hits 2, it's going to start righting itself. Yeah, you see there. It is rocking backwards and forwards a lot. Maybe we need to put something in the code that says if you're only like a little bit off, then don't go 45 degrees. Maybe just 10 degrees. Yeah, that sounds like a good idea. So what we're going to do is we're going to duplicate all this code here. Okay, we're going to say if you are only got a horizontal speed of 1 difference, okay, then the angle, just use 10 degrees or minus 10 degrees, okay, and then for if you've got a horizontal speed, let's say the horizontal speed gets down to about 10, then let's make it 10. So we've got horizontal speed deceleration for 10, and we've got a different algorithm for horizontal speed deceleration for above 1. Okay, so it does a much smaller angle. Let's try that. Okay, so once again coming over the launch pad, we've got a horizontal speed. It's using the 10-degree one for some reason. Yeah, we've got them the wrong way round. This one wants to be above that one, because it's the order of priorities. So the ones at the bottom are the ones that get executed last, and they're the ones that get to save what they are. Right, try again. Come on, this time. This time we're going to get a 45-degree angle. There's our 45-degree angle. As soon as we get to within 10 horizontal speed, that 45-degree angle will change to a 10-degree angle, and we level off a lot easier, I think. Maybe. It's still wobbling a little bit. Why is it wobbling a little bit? It's doing okay, but it seems to be swinging backwards and forwards quite a lot. It's because it's just dipping over into that 10, isn't it? I don't think that 10's big enough. No, I don't think it is. Let's try it with a 20. Yeah, if it's greater than 20, we'll do 45 degrees. And if it's just greater than 1, we'll only do 10 degrees. Yeah, that'll do. So there's our 45 degrees deceleration. And we've gone beneath 20 now, so the ship is gently... Oh, I know what's going on here. One of these should be a minus 20. One of these should be a minus 1. Yeah. There. That should be a minus 1, and that should be a minus 20. Oh, for crying out loud. I'm a little bit frustrated at myself for that, because if I'd have spotted that earlier on, this code would have worked a lot better. Now, am I confident this time? Probably, maybe. Yes, I think. Let's try it. So there's our 45 degrees deceleration. When it gets beneath 20, it turns to a 10 degrees deceleration. And I think 10 degrees might be fine, but I think we can get it lower than that. And then it just straightens up when it gets to 1. I like that, but this 20 I think can be 10. Now that I've fixed it, this 20 can be 10. So we'll keep this one for this landing. This is our first official landing on approved code by Hellish, and we haven't run out of fuel. We're right in the middle almost of that landing zone, and there is our lander. Now, we've been writing some code. We could have landed this a lot easier earlier on, but I've been trying to make it quite robust. Let's see what we do in the next test case. So in the next test case, we already have a horizontal speed of 108 in the negative direction. Immediately, our craft goes into a kind of glide mode, which is fine, but now it needs to decelerate, and I don't know whether it's going to decelerate fast enough over the landing zone. It's turned 45 degrees, but I really don't think it's going to make it very well. No, look, it's going way, way over there. So what we're going to do is we're going to add an extra 2 conditions to our code right down here at the bottom, and we're going to say this is our massive horizontal H-speed brake. So if we're flying across the screen like we are now, we need to sort this out. We're just going way too fast. And what we're going to do is we're going to steal the horizontal speed code from here. We're going to put it in here. And we're just going to say, let's just get rid of, get our spacing right. I always find that you have to get your spacing right in order for it to be nice and easy to read. It's quite important. And let's just make sure. Also, I mean, I can't handle it if it's not right. It has to be in line. There we go. So we're going to say if our horizontal speed is greater than, I don't know, 60 meters per second in either direction, then we're going to angle at 45 degrees to slow down, because we're just going too fast. I'm not having it. Okay, so let's execute that. Our craft was flying way over there. Now this time it will immediately turn into the negative direction and blast sideways to try and slow its horizontal speed. Once its horizontal speed gets less than 60, those last 2 rules will not activate. There it is, it goes less than 60, it's now gone into its hover glide, and I think the existing code that we have should be able to guide this down quite nicely. As soon as we go past this first point, it goes into a slowing down phase. So there it's going over the landing pad now, over the landing zone. It's gone into its slowing down phase. It will slow down until it gets to 10 meters per second horizontal speed in that. Then it will go slightly at a new angle until we get to 1, and then straight. Fantastic, look at that. Just with a tweak we were able to successfully go over this. And there's some nested ifs here and what I call cancelling ifs. We've got some values that we're setting, and then if a condition is true, we're overwriting it with a new value. But to be honest, this is working quite well. We've been able to land the lander there. Now, initial speed and the wrong side. Let's see how our code handles this. So, we're going the wrong way, and we're going the wrong way fast. Our ship turns round and puts the brakes on big time until it gets less than 60 meters per second in the right direction. Now, that is still now trying to level out because we're going more than the wrong way. And is it just going to land flat there? No, it went over the edge of the landing zone and continued to blast back a bit. Oh. It's slowing down. It's got a bit of an angle on it. There we go. Well, the code was able to handle that. And to be honest, I was quite surprised. I thought maybe it would overthrow it. But with the numbers we've got punched in here, it seems to be working out quite well. And we are safely landing. And there's our lander. Brilliant. Okay, deep canyon. This sounds dodgy. Let's see what we get. Let's see what we get here. So we're blasting over to the right, and we're going way too fast for that. So we're going to put a deceleration in. So there's our massive H speed brake kicking in now. Now this is a problem. Are we going to be able to clear this peak? I don't think we are, you know. Are we going to clear the peak? Oh, we just cleared the peak. And now we're over the landing zone, so our craft should tilt sideways to get rid of our horizontal speed. There it is. Horizontal speed dips beneath 10, so it should angle less now. And then horizontal speed to 1, angle even less now. Brilliant. And a landing. Oh my goodness. We managed to get it into the deep canyon. Fantastic. Now, the next one is called high ground. All the code I've done so far is to do with descending. If this is really high up, we're going to have a problem here. So let's give it a run and see what happens. I'm not confident about this one. Look at, oh my goodness, all the way over there on the left hand side. Well, our horizontal speed is not above 60, so our craft is just floating across, and its vertical speed is dropping. It's hovering. It's almost hovering. It's going between vertical speed of 1 and 2 in the descent. So this might actually work. It depends whether it can slow itself down quick enough before it lands. It needs to be able to slow it down from the horizontal speed of 58 meters per second to the left to, well, our code goes to 1. That's well within tolerances. So we're just about to go over the edge of the landing area. There it is. It's angling across. Is it going to be able to stop the speed before it misses the area? There's the 20. Is it going to hit 10 in time? There's the 10. It's leveling out. It's getting to 1. There's the angle of 1. Is it going to level out? It leveled out! A champion! Fantastic! Well, there we go, folks. With this code here, we've got a load of ifs. It probably might have been able to done a little bit smarter with a bit of a more smarter algorithm, but this seems to be able to handle pretty much anything that it was thrown at it for now. So, there we go. All jobs are good on this one. So thank you very much for watching, especially if you watched the whole episode. It's been a bit of a longer one, but also remember of the hour of code that's going to be happening. Check all the links and information in the description. Thank you for watching. Leave your thoughts, ideas and questions down in the comment section below as always. And yeah, I'm quite pleased about that. Yeah, not bad. And remember, if your code doesn't go right, remember if things go wrong, they don't really. They just get interesting. Thanks for watching. Take care. And goodbye.